Good evening, guys. I hope you are able to hear me. Hi, Rakshana, Ivan. Am I audible?
Yes, sir.
Yes, sir.
Okay. So give me a second. We're going to start the class now. All right. So as per the plan, today we are going to revise electromagnetic waves. Very small, less weightage obviously because chapter is small, but obviously it will anyhow give you 4 marks to 5 marks if your luck is good. So simple small chapter where I can assure you how the questions are going to come in the examination, in the board examination. If you study that, you are going to get the marks. So we'll revise that first, and then we will go to ray optics revision today. Let us see, we will try to complete it. If not, we will keep another class to complete that ray optics revision. But today, our plan is to revise electromagnetic waves and ray optics. Fine. Let us start without wasting any time. And first, let us start talking about electromagnetic waves. I hope everybody is able to hear me. Rohit, am I audible? Amrita, audible, right?
Yes, sir.
Okay.
Yes, sir.
So, Amrita, don't forget to take the notes. When I meet you in the next class, you should not say I forgot to take the notes, sir. Okay. So, yeah. Right. So coming to electromagnetic waves. So in this chapter, what things are important? First thing is understanding the basics of displacement current. Second is Maxwell's equation. Third is applications of electromagnetic waves. That's all. If you know the basics of displacement current, if you know Maxwell's equations, there are 4 equations I'll write on the board. I'll make you understand. So 4 Maxwell's equation. One is concept of displacement current, and the third is electromagnetic spectrum. Electromagnetic waves, its wavelength, its frequency, its application. If these 3 you are knowing well, you will not lose any marks on this chapter. Moreover, 100% the question is going to come from applications of electromagnetic waves, which is you should know what is the wavelength of microwaves, radio waves, X-rays, gamma waves, everything. And you should also know what is the frequency of them, what is the source of them, what is the application of them. If you're knowing all these things well, then I can assure you, you will not lose marks in the board examination. Okay, we'll start one by one. First, we will talk about the concept of displacement current, which gives rise to the modified Ampere circuital law. When I'm saying displacement current, I am already meaning that I'm going to talk about modified Ampere's circuital law. Okay, what is that? So, up to the discovery of displacement current, people were aware only about the current produced by the movement of charged particles. So, when the experiment was being conducted, where there was a capacitor chosen, and this capacitor was connected with a battery like this. And what did Maxwell do? He kept compass. He kept compass here, and he kept compass here. So, as per the Ampere's circuital law, if a wire is carrying a current, it will have magnetic field across it. And what is the magnetic field? Ampere said that as per the Ampere circuital law, closed integral of B dot dl is equal to mu naught times I. I hope you know this. Ampere circuital law. He said that integral of B dot dl is equal to mu naught times current enclosed by the Amperian loop. But what did Maxwell do? In his experiment, this is Maxwell's experiment. In his experiment, he connected a capacitor with a source of power, a battery, and he tried to find check whether my needles are deflecting here and here or not. As he expected, needle got deflected here, and the cause of deflection is quite obvious. Why I'm saying quite obvious? Because if I'm drawing an Amperian loop here, there is a current flowing through it, and since current is flowing, there is a current enclosed by an Amperian loop, magnetic field must be there, and it is given by integral of B dot dl is equal to mu naught into I. Surprising thing was, this compass also was getting deflected, which was unusual because there is no current passing through this. It's a capacitor, two plates. No current is moving. There is a gap between them. And here we are expecting no current to be there because there is no magnetic field. But there was a deflection. If I'm drawing Amperian loop here, what is the current enclosed? Zero. If current enclosed is zero, magnetic field must be zero. That is what Maxwell thought. But he was surprised to see that the needle was deflecting here also. It means some current is present here. And this current only he called as what current? Displacement current. Are you getting what I'm trying to say? This was conduction current, which is flowing in the wire. The place where the current is flowing without wire, he called that current as displacement current. And how did he justify that presence of that current? He said that we have learned in the electromagnetic induction concept, Faraday told us. Faraday said that whenever there is a change of magnetic flux, there is an induced EMF. Am I right? d phi by dt is equal to E. That's what Faraday told. Lenz modified and Lenz told that minus d phi by dt is equal to E. So induced EMF is always rate of change of magnetic flux. Maxwell said, what about electric flux? Electric flux can also change, right? Obviously, it can change. For example, here if you see, when we are connecting the capacitor with the battery, initially charge is almost negligible. Then slowly charge starts to build up here. Not immediately, it will take some time to build. When the charge is building up, the electric field is slowly changing. Am I right? Initial electric field 0, then little more, then little more, then little more, then little more. So there is a change in electric field. And this change in electric field is only causing the current to come. So as per Maxwell, like how change in magnetic field is producing induced EMF, same way change in electric field is also producing a current, and that current he called as displacement current. So he gave the formula of displacement current. He told that displacement current is equal to epsilon naught into d phi by dt, that is d phi e by dt. Remember this. Displacement current formula is epsilon naught into d phi e by dt, where phi e is electric flux. So whenever electric flux is changing, that will lead to current called as displacement current. And then he modified the Ampere circuital law. And in his modified Ampere circuital law, he said that closed integral of B dot dl is equal to mu naught into IC plus ID. He told what current is told by Ampere is conduction current. And what is this new current? Is displacement current. If you add this conduction current and displacement current, that only is total current in the circuit. And if I further open it, it will become mu naught into IC plus mu naught into epsilon naught into d phi e by dt. This is called as modified Ampere's circuital law. Is it clear to you? This is important. Sometimes it's coming as 2-mark question to write about the theory of this ACL, modified ACL. Theory they will ask you, this equation they may ask you, this concept they may ask you. So remember, the concept is very simple. Whenever there is a change in electric flux, there is a current coming, and that current is called as displacement current. Like how changing magnetic flux is producing induced current, changing electric flux produces displacement current. I hope you can remember this. Changing magnetic flux, induced current. Changing electric flux, sorry, displacement current. This was the modified Ampere circuital law. After which Maxwell gave his equations, famous equations. It's called as Maxwell's equation. Whatever you have learned in all the chapters till now, everything he summarized. Come fast, man. Everything he summarized. So he summarized by giving 4 equations of electrostatics and magnetism. Electromagnetism, he called it. So the 4 equations goes like this. The first one is from the first chapter, which is Gauss law. Gauss law in electrostatics says that integral of E dot dA is equal to, man, you came late, at least pay attention here. Integral of E dot dA is equal to Q by epsilon naught. Am I right? Q net by epsilon naught. This is what is called as what? This is Gauss law. So it is called as Gauss law in electrostatics. This is the first equation which he summarized. Gauss law in electrostatics. The second equation that he told was Gauss law in magnetism, which you may not would have heard much. It is integral of B dot dA is equal to 0. Very important. Now, what is the meaning of that? Nowhere we learned this topic in the previous chapters. But what is the meaning of that? This is called as Gauss law in magnetism. Gauss law in magnetism. Now, what is the meaning of this? Please pay attention. It means that I have taught in the 5th chapter to you that magnets always exist as dipoles. Can magnetic monopole exist? Can you have a North Pole or only South Pole? Never. You will always have North Pole, South Pole together. So magnetic monopoles never exist. Right? So if you draw a surface, Gaussian surface, it will always enclose north, south together. And so the net magnetic field will become 0. Net magnetic flux, actually. Are you getting my point? So what this thing says, B dot dA will be magnetic flux. Net magnetic flux in an enclosed surface is always 0. Why? Because magnetic monopoles does not exist. Once again, this question comes in assertion and reason type. This justifies that magnetic monopoles never exist. Never exist. These things will come in the examination. Come fast, fast, fast. Magnetic monopoles never exists. How it came? Because if a monopole was existed, this value will not be 0. But magnetic monopoles never exist. Always it will be dipole only. Dipole means magnetic, we call it as magnetic dipole. It is also called as short magnet, isn't it? Then comes the third law, which you learned in electromagnetic induction chapter, Faraday's law. I will include Lenz's law and write. So as per Faraday's law, you know that d phi by dt, I should write minus d phi by dt, which is obviously magnetic field, minus d phi by dt is equal to induced current, induced EMF actually, induced EMF, isn't it? I hope you remember Faraday's law. Faraday's law says that induced EMF is the rate of change of magnetic flux. So you know that EMF can be written as electric field into length. Second chapter. You know that E is equal to minus dV by dx, isn't it? So electric field is always equal to electric potential by distance. So if you want to write electric potential, it will be electric field times distance. So I can write integral of E dot dl. Remember like this. Electric field into distance will give you electric potential, that is EMF. So EMF is equal to minus d phi by dt. This is also called as Faraday's law. Faraday's law. This is third equation of Maxwell. See, Maxwell is just summarizing all the equations, not giving his own equation. His equation is only the fourth one, which we discussed just now. We understood that integral of B dot dl is equal to mu naught into IC plus mu naught into epsilon naught into d phi E by dt. This is called as modified Ampere circuital law. Sometimes in board examination, they will just ask you to write all the Maxwell's equation. You are supposed to write all these 4 equations. Sometimes they may ask a question in assertion and reason category from this second law. I explained to you what is the meaning of that. Sometimes they will be very specifically asking what is Faraday's law as per Maxwell's equation. If you write and come, Faraday's law is E is equal to d phi by dt. They will not give marks to you. Yes, Faraday's second law is that only. Faraday's second law is magnitude of induced EMF is equal to rate of change of magnetic flux. But they're not asking that. They're asking write Faraday's law as per Maxwell's equation. Then you must write integral of E dot dl is equal to minus d phi by dt. And how it has come, I've explained you there. Electric field is equal to potential by distance. So when you multiply electric field and distance, you get potential. That is only EMF. So very important. These are the 4 equations of Maxwell. Then comes the next topic in this chapter, which is about the relationship between mu naught and epsilon naught. Because you saw in the previous page, I wrote this mu naught into epsilon naught. So it was found that if you see here, you will realize that K is equal to 1 by 4 pi epsilon naught. Am I right? First chapter. Its value is how much? 9 into 10 to the power 9. You know that mu naught by 4 pi is equal to 10 to the power minus 7. Yes or no? These both things you know, right? This is from 3rd chapter. Actually, 4th chapter. This is from 1st chapter itself. That is 1 by 4 pi epsilon naught is equal to 9 10 power 9. Mu naught by 4 pi is equal to 10 power minus 7. If I divide 1 by 4 pi epsilon naught with mu naught by 4 pi, what do I get? I'm going to get 9 into 10 to the power 9 divided by 10 to the power minus 7. What will happen here? 1 by 4 pi epsilon naught into 4 pi by mu naught. What will happen here? 9 into 10 to the power 16. 4 pi gets cancelled. You are going to get the expression of mu naught epsilon naught. Mu naught epsilon naught will become equal to 1 by 9 into 10 to the power 16. 9 into 10 to the power 16 can be written as 1 by 3 into 10 to the power 8 whole square. And 3 into 10 to the power 8 is what? Speed of light. So I can write mu naught into epsilon naught is equal to 1 by c square, or c is equal to 1 by root of mu naught epsilon naught. These things are very important. Many a times it has come in the board examination about relationship between mu naught and epsilon naught, which is equal to mu naught epsilon naught is equal to 1 by c square. How it came, I have explained you here. Once again, I have taught already these things in the previous classes. Then another type of question which comes in the board examination is draw the electromagnetic wave. Most simple question. If they ask you to draw the electromagnetic wave, you must know that I will draw electric field, and I will draw magnetic field. This gives me electromagnetic wave. That is oscillating electric field and oscillating magnetic field together gives you electromagnetic wave. Represent this, right? Electric field. This one is magnetic field. And right there, oscillating electric field and oscillating magnetic field combined together gives you electromagnetic waves. One more question that comes in the board examination. What is the source of electromagnetic wave? What is the answer? We should say accelerating charge particle. Remember the answer? What is the source of electromagnetic wave? Source of electromagnetic wave is accelerating charge particle. These things are direct questions here. Accelerating charged particle. Charged particle. Direct question comes from here. So please remember these things. Now comes the second part of the chapter, which is completely about spectrum, which I expect you to draw a chart and remember the values. Before the examination, you should have full clarity about what are the values of wavelengths, frequencies, source, and application. If you remember for all the waves, starting from the highest wavelength, that is radio waves, to the lowest wavelength, that is gamma waves. So if you remember everything about radio, micro, everything till gamma, its wavelength, its frequency, its source, and its application, definitely one question will come from it. Definitely, I'm saying. And how the question will come also, I've told you in the past. They will give you application, they'll ask you the wave. Or they will give you the wave, they will ask you the application. They will give you the wavelength, they will ask you to identify the wave. Or they will give the wave, they'll ask you what write its wavelength and frequency. So if you remember all this chart, then you can definitely take one question. And don't confuse in that. Sometimes you will feel that some range of wavelengths or frequencies is coming in two different waves. Some value of wavelength may come in radio also, may come in micro also. So don't worry if that happens and that value is given in the examination, they will give marks for both. But if you write wrongly, they will not give marks to you. So every wavelength of each wave, its frequency, its source, its application should be in your head before the examination. If you're remembering that, one question will definitely come from there. Next comes the next chapter, which is ray optics. Very huge, very big chapter. I'll try how much I can do today. Let us see. If I'm able to finish fully, it's fine. The whole revision, it's a big chapter. Now let us start the revision of ray optics, which is having almost the maximum weightage in the board examination. For the students who are having trouble in ray optics, and at least I should not say it now because it's November only, try to learn it fully. But if you are having some choice-based learning, I'll not learn the whole thing, then definitely choose optical instruments. Because in the board examination, from optical instrument, question is certainly going to come. If you're selecting and studying, then always select optical instruments. It's the most important part. A small area having more marks. But now you should not think about November month we are there. Still we have time for preparation. So you should not select and study. Study everything. And always remember, board exam, nobody can judge. Question can be very easy, medium, tough, or very tough. Last 4-5 years, if you see, some year question has been very easy in physics. Sometimes like last year, it was very tough. Last year also it was tough. So we cannot expect how the question is going to come. Be prepared for the worst case scenario. If you study in the less level, you may fail also in the board exam. Remember that. So I'm always cautioning you, study and study hard. Don't do selective study, at least now. In January month also you can do. But now November month is there. Try to study all the topics. Don't miss anything. Coming back. In this chapter, the first topic is about reflection. And this is directly linked with 10th standard reflection. That is, you must remember what is the meaning of plane mirror, concave mirror, convex mirror. Concave mirror is converging, convex mirror is diverging. What is the meaning of object distance, image distance, focal length? If I keep the object at various positions, how will the image of the object will form? These things are not given in NCERT itself, but you are supposed to remember that from 10th standard. That is, if the object is placed between C and F of a concave mirror, image will form beyond C, real, inverted, enlarged. This should be in your head. It does not come by mugging up. Don't think I have mugged up. Since I am teaching again and again, learning again and again, I am remembering it. Same way you also. Object kept at F, image will form at infinite, real, inverted, highly enlarged. Object kept at C, image will form at C, real, inverted, same size. Object between F and P, image will form inside the mirror, virtual, erect, enlarged. Like that, all the object positions, its image, nature, size, and characteristics. Everything you should have in your mind. Same for convex mirror also. And then comes the first topic which is important in the board examination, which is derivation of mirror's formula. Derivation of mirror's formula, which I am not going to do now, because if I start doing it now, full class will go in that itself. But always remember, in derivation of mirror's formula, what you should remember is, if you're taking a mirror like this, then how I remember during my time of studies, if it is P, if it is F, if it is C, keep the object beyond C, one ray will go. I'll not take this ray itself. One ray which is going through pole will get reflected like this. One ray passing through focus after reflection will become parallel to principal axis, isn't it? And one ray passing through center of curvature will retrace its path. These 3 rays are enough. So keep in your mind, while deriving the mirror's formula, which 3 rays I will take? One ray passing through pole, second ray passing through focus and becoming parallel to principal axis, and third ray passing through center of curvature, retracing its path. So here, if this is A, this is B, this is A dash, and this is B dash, I am going to have this triangle. I hope you're able to see this triangle and this triangle. First, for these 2 triangles, you will take similarity and you will write the ratio equation. Same way, if you see, we have this triangle, ABP, and this triangle, A dash, B dash, P. These 2 triangles also will prove similar, and you will take the corresponding ratio. Then equate both. That's all. If you do with proper sign convention, you will automatically get 1 by F is equal to 1 by V plus 1 by U. and magnification, which is Hi by Ho is equal to minus V by U. Automatically it will come. I have done in the class. Check your notes or check the video of the class. I have already done this in detail in the class. It's very simple also. That only I'm repeating. So first you should take these two triangles and prove them similar. Obviously they are similar, 90 degree, 90 degree, and then vertically opposite angle. Same way, this big triangle ABP, A dash B dash P. These two triangles also, this angle are same because angle I is equal to angle R, and 90 degree, 90 degree, they are also going to be similar. When they are similar, their corresponding ratios will be equal. Equate both the ratios. Both sides you will have Hi by Ho. Equate the right hand side. You will automatically get 1 by F is equal to 1 by V plus 1 by U. One step more you should remember. In one step, we are going to divide by UVR. Don't forget this step. Dividing all the terms by UVR. When you do that, you will get the mirrors formula. Also the magnification formula. This is the first important thing in this chapter. Okay. Then comes the refraction and the basics of refraction, where it starts with the understanding of refractive index. So what is the refractive index? The refractive index is the measure of optical density. That is, how much will a light bend in a medium? That is governed by refractive index. The higher the value of refractive index, more bending it causes. Lesser the value of refractive index, less bending it causes. So how much bending will be caused is purely governed by refractive index of a medium. And what is the definition of refractive index? It is the ratio of speed of light in vacuum to speed of light in any medium. So always remember that if you divide the speed of light in vacuum, which is 3 times 10 to the power 8, with speed of light in the given medium, you will get refractive index of the given medium. So for example, if I say speed of light in a medium is 2 times 10 to the power 8, what is the refractive index? So I'll divide 3 times 10 to the power 8 by 2 times 10 to the power 8. When you solve this, you'll get 1.5. So refractive index becomes how much? 1.5. What is this medium you knowing? It is glass. Remember this basic thing. So when you divide the speed of light in vacuum to speed of light in that medium, you get the refractive index of that medium. For example, mu1 is equal to C by V1, mu2 is equal to C by V2. And from here, if I divide both, that is, if I write what is mu2 by mu1, when I do so, what I'll get, you see, mu2 by mu1 will become equal to C by V2 into V1 by C. CC gets cancelled. I am getting mu2 by mu1, which is called as refractive index of second medium with respect to first medium, will become equal to V1 by V2. And you know very well, V is equal to C lambda. CC will get cancelled, which will become equal to lambda 1 by lambda 2. Now, this also becomes a very important part, because from here the questions are coming in the board examination. How it is coming? If you see this expression, mu2 by mu1 is equal to V1 by V2 is equal to lambda 1 by lambda 2, there are two things you are getting from here. First thing is refractive index is inversely proportional to velocity. Refractive index is inversely proportional to wavelength. And velocity of light is directly proportional to wavelength. Am I right? These three things you're understanding from here. Because mu2 by mu1, V1 by V2. mu2 by mu1, lambda 1 by lambda 2. But V1 by V2, lambda 1 by lambda 2. From there, you're understanding that the refractive index and velocity are inversely proportional. Refractive index and wavelength are inversely proportional. But wavelength and velocity are directly proportional. It means that if the refractive index is going to increase, wavelength is going to decrease, or vice versa. That is the reason when light is passing through prism, different colors will have different deviation. We'll come to that when I talk about the prism. But remember that red light will deviate the least, because red light has the maximum wavelength. Violet light will deviate the most, because violet light has least wavelength. And how much will the light bend? Who decides that? Refractive index decides that. So since violet light has least wavelength, it has maximum refractive index, causing maximum deviation. Red light has maximum wavelength. It has least refractive index, having least deviation. That's the reason why you have more deviation in violet light, less deviation in red light. Just for the knowledge I'm telling. So that is about the refractive index. I hope it is clear from here about this thing, which is very important for the board examination. Also from here, we should understand what is laws of refraction. There are two laws basically. One law is incident ray, refracted ray, normalized in the same plane. Second law is sine of angle of incidence to sine of angle of refraction is always a constant, and that constant is called as mu2 by mu1. That is the refractive index between two mediums. If I rearrange, it will be mu1 sine I is equal to mu2 sine R. Very versatile equation. In many questions, in many numericals, it will be directly used. In many numericals, in many questions, it will be directly used. Remember that, how it will be used? To find R generally. Suppose they are giving you refractive index here is 1.5. Refractive index here is 1.33. And then they say you, here light is hitting at an angle of incidence of 30 degree. So obviously it is going from a denser medium to a rarer medium. It will bend towards the normal, away from the normal. Denser to rarer, away obviously. So it will go like this. So we know that this angle will be more than 30 degree. But how much is the angle going to be? How to find that? By using Snell's law. So mu1 is 1.5, sine 30 is equal to 1.33 sine R. Solve the equation, get the answer. I hope you are understanding this. So Snell's law is used to find sine of angle of refraction easily by understanding this mu1 sine I is equal to mu2 sine R. Expect questions to come from here, where they will give you one angle, and by this knowledge you can find the other angle. Then in this chapter comes the next concept, which is of real and apparent depth. Real and apparent depth. So I always say this to you, that if you have, suppose the example, best example can be in a beaker. If I'm having a coin, and if you're seeing this coin from the top, this coin will look raised for you. It will have a different position for you. Why the coin looks raised? Because the light which came to your eye bent, and the apparent position of the coin only is visible to you, not the real position. This is called as real depth, D. This is called as apparent depth, D dash. So always remember that D dash, that is apparent depth, is equal to real depth into mu1 by mu2, where mu1 is the refractive index to where the light is going, and or if you want to confuse, if you're confusing, write mu1 this and mu2 this, then it will become mu2 by mu1. Completely your wish what you want to write. If you write mu2 by mu1, then the mu1 will become refractive index of the medium from where the light is coming, and mu2 will become refractive index of the medium to where the light is going. Always remember this. I have seen many students making mistake in the numericals just by taking wrong mu1 and wrong mu2. They'll know the formula. The formula is D dash is equal to mu2 by mu1 into D. They'll write the formula also correctly, but they'll get the answer wrongly. You know why? Because they will take mu2 and mu1 ulta. Common sense, if you apply, you will understand that. Always remember, when the light is passing from a denser medium to a rarer medium, then D dash will be less than D, like in this case. And if light is going from rarer medium to a denser medium, D dash will be more than D. D dash will be more than D. In the class, we have taken an example also. Bird and the fish example. You remember the question? When the bird is seeing the fish, then for the bird, the fish's apparent depth is lesser than the real depth. But when the fish is seeing the bird, the real height of the bird is less than, that is, apparent height is more than the real height. So because when the bird is seeing, light is coming from air to water, which is rarer medium to denser medium. So apparent depth will increase. When the bird is seeing the fish, light is going from water to air, denser to rarer. That's why the apparent depth is less than the real depth. So if you are forgetting this, remember this bird and fish example. It will be easy to remember that, because I'm telling you, now you are understanding. In exam, you will confuse in what is mu1, what is mu2, and you will get a wrong answer. So always have a check
Sir,
from where the light is
repeat
coming.
that again.
I'll repeat, Rohit. I said that whenever the light is traveling from a denser medium to a rarer medium, the apparent depth will be lesser than the real depth. For example, if you are having a fish in the water, like this, there is a fish, and a bird is seeing from the top. If the bird is seeing the fish, light is going from the bird to the fish, right? So it is going from a denser medium to a rarer medium. So the apparent depth will be lesser here. The fish will be little above. But if the fish is seeing the bird, light is coming from where? Rarer medium to a denser medium. I told when the light is going from rare to dense medium, then the apparent depth will be more than real depth. So the position of bird will be more than the real position. Are you clear, Rohit? Understanding?
Yes, sir.
Yeah, remember this. And I have solved some questions in the class also when I was teaching this concept to you. So if you want, you can go through the video and once again revise that. Those who are new to the class, those who are there in the class, they can see the previous questions. We have solved questions based upon this in the class to find real depth and apparent depth. Okay, it's important for the board examination. For board exam, it is important. Okay. Next in this chapter, we have to learn about the concept of refraction through prism. So, refraction through triangular prism. Triangular prism. Now, what is that? So, I hope you know that whenever the light is going, I'm drawing it here, there is a prism and light is entering a prism. This is the angle of incidence, isn't it? This is a normal, obviously. What happens? Light ray goes and hits here, right? After it hits here, I'll once again draw normal. This will become angle of refraction 1. This will become angle of refraction 2. Now the light is traveling from denser medium to rarer medium. It will bend away from normal. This is called as angle of emergence. So angle of incidence, angle of refraction 1, angle of refraction 2, and angle of emergence I have drawn in the diagram. This angle is called as angle of prism. Never forget that. And I have told in the class that if you extend the incident ray and you extend the emergent ray, what is this angle? That angle is called as angle of deviation. So angle of deviation is how much your emergent ray is deviated from the incident ray. Del I A R1 R2. Everything should be very clear to you. As I have drawn angle of incidence, refraction 1, refraction 2, angle of emergence. If you derive it, I have done in the class, A will become equal to R1 plus R2. Remember this? Now, don't think that angle of prism is always a top angle. Not like that. Purely depends upon where the light is entering, where it is exiting. If light is entering like this, exiting like this will become angle of prism. If light is entering like this, exiting like this will become angle of prism. So, which side the light is entering, which side the light is exiting, the angle bounded by the incident ray and emergent ray only gives angle of prism. So, never have a thinking like always the top angle in the prism is the angle of prism. No. Angle of prism is purely governed by incident ray and emergent ray. So, remember this very clearly. So, I told you angle of prism, if you find by derivation, it will come equal to R1 plus R2 and I plus E is equal to del plus A. This also I have derived in the class. This also I have derived in the regular class itself, where you must remember that angle of incidence plus angle of emergence is equal to angle of deviation plus angle of prism. Once again, from these two equations, expect questions to come in the board examination and you should be able to solve it. Then comes the concept of angle of minimum deviation. This is also very, very important concept. Angle of minimum deviation. What is that? So there are two, very one important graph here. That is the graph drawn between angle of incidence and angle of deviation, isn't it? Actually, deviation will come here, incidence will come here. So the graph is something like this. In your school lab also you should have done that. And it is also there in the theory. So I have drawn a graph between angle of deviation and angle of incidence. If you see this point, the lowest point, this is called as angle of minimum deviation. That is the angle at which there is only one angle of incidence. If you see any other point, like suppose if I draw, suppose I'm drawing any other deviation, I'm having two values, right? This will become angle of incidence, this will become angle of emergence. If I draw any other line, see, for this deviation also we have two values, angle of incidence, angle of emergence. For every other angle of deviation, what we are going to have? We are going to have 2 points, angle of incidence, angle of emergence. Only at angle of minimum deviation, we have only 1 point. It means at this point, what is going to happen? Angle of incidence will become equal to angle of emergence. These concepts are highly important for the board examination. So at angle of minimum deviation, always remember that the angle of incidence will become equal to angle of emergence. That is at angle of minimum deviation, I will become equal to E. And one more thing will happen. R1 becomes equal to R2. Never forget this. At angle of minimum deviation, angle of incidence and angle of emergence are same. R1 is equal to R2. So what will happen? If I write the equation of mu, which is equal to sin I by sin R, it will become sin A plus del min by 2 divided by sin A by 2. Once again, a very important derivation for the board examination. And once again, I am seeing last 3-4 years trend. Every year one question is coming from here. If I see last 3-4 years of trend, every year one question is coming from angle of minimum deviation. So have the idea about these things. Don't get confused. Angle of minimum deviation is the angle where the deviation is least. And at this point, angle of incidence and angle of emergence are same. Angle of R1 is equal to angle of R2. And relationship of angle of minimum deviation with refractive index is mu is equal to sin A plus del min by 2 by sin A by 2. So, especially to the people who not attended my ray optics class. So there are some people who would have not even seen my ray optics class. I highly recommend you, in your Wisdom Academy app, you have all the previous lectures. Go there, see the ray optics class videos. Because now if you are seeing those who have attended the class, for them it is easy. Everything I have derived. But now I am just going fast because I want to finish the chapter revision. So I'm not teaching in detail. Somebody may be wondering how he wrote these things and all. I have written the class derivation. I have taken this quadrilateral and proved how this came. So these derivations are very well solved in the videos. If you want to go and see after seeing the video, if you have doubt, come back to me. I don't have any problem. But now I am recalling all the concepts and telling you how the questions will come in the board examination. That's what this class is all about. We are revising and we are discussing the important questions. Coming back. Next topic in this chapter is very important is total internal reflection. Very, very important concept. Once again, the questions are coming from here frequently. Total internal reflection. What is that? Total internal reflection. What happened, Mukesh, man? Any problem? You want to go home, you can go. But listen properly. Don't disturb others. Already Simeon is half asleep. Since you're talking only, he's awake. So to make him awake, you're talking. Huh? I know how much you're awake, man. I cannot read. I can read your mind. Eyes are open, mind is sleeping. Okay, coming back. TIR, total internal reflection. What it says? It says that whenever the light is traveling from a denser medium to a rarer medium, what happens? It bends away from normal, isn't it? Do you agree with me? Whenever light is traveling from a denser medium to a rarer medium, how it bends? Away from normal it bends. If I increase the angle of incidence, what happens? Angle of emergence also increases. Do you agree with me or not? At a particular value of angle of incidence, the angle of emergence becomes 90-degree. Refraction, I should say. Why I'm writing emergence here? It should be angle of refraction, isn't it? So at that particular angle at which the angle of refraction becomes 90-degree is called as critical angle. So at critical angle, the R becomes 90-degree. Remember that. And what if the angle of incidence is more than critical angle? We will have total internal reflection where the light will once again reflect back in the same medium. So always remember that if there are three possibilities for a light, if light is going from denser medium to rarer medium, there are three possibilities. First possibility, angle of incidence less than critical angle. Second possibility, angle of incidence equal to critical angle. Third possibility, angle of incidence more than critical angle. If angle of incidence is less than critical angle, it will undergo normal refraction. That is, light will refract and go ahead, like the first case here. If angle of incidence will be equal to critical angle, we will have grazing. Grazing means what? Angle of refraction will become 90-degree. That is the meaning of grazing. And third scenario, angle of incidence more than critical angle, we are going to have total internal reflection. Keep this in your mind because the numericals will come from this, and you can understand the numericals only if you understand its logic. That is, if you see like this, there is a prism and the light is entering here. What will you do? If you want to find the angle of refraction, R1, easily you will find by Snell's law. Mu1 sin I is equal to mu2 sin R1. You will find R1 easily because they would have given value of mu, suppose 1. Here mu, suppose root 2. Then what will happen? Ray will come and hit here. Now, you should very carefully determine whether this angle R2 is more than critical angle, less than critical angle, or equal to critical angle. Because if R2 is more than critical angle, it will not come out like this. It will go inside itself. That possibility is always there. So whenever light is hitting a interface, always remember that you will check whether the angle of incidence is more than critical angle or less than critical angle. If it is less than critical angle, no problem. It will like usually it will come out. But coming out of light is only possible if the angle of incidence is less than critical angle. If it is equal to critical angle, it will come out like this, isn't it? If it is more than critical angle, it will undergo total internal reflection. I hope you understand this. How to find critical angle? Another question. So for that, the formula is mu is equal to 1 by sine C. By this formula, you can easily find critical angle. That is, sine C is equal to 1 by mu. C will become equal to, if I write here, sine C is equal to 1 by mu. So C will become equal to sine inverse of 1 by mu. So if you have the refractive index of the prism known, you do sine inverse of 1 by mu, you will easily get what is the critical angle. For example, mu is root 2. What is sine inverse of 1 by root 2? What is sine inverse of 1 by root 2? How much degrees? 45 degrees. It means critical angle is 45 degree. If angle of incidence is 30 degree, it will undergo refraction. If angle of incidence is 45 degree, it will undergo grazing. If angle of incidence is 60 degree, it will undergo TIR. So how to find critical angle? By writing sine inverse of 1 by mu. One more important thing. One means what, you know? Refractive index of outside medium, air. So if the outside medium is changing, then C will become equal to sine inverse of mu of surrounding divided by mu of prism. Remember this. This is the formula of critical angle. Suppose they tell outside medium is some liquid having refractive index of 1.3. Then you should put sine inverse of 1.3 by √2 or whatever they gave in the equation. So please be remembered that sine inverse of 1 by mu should be used only if outside is air and you have a prism. Because there are questions in the board examination where they will change the outside medium itself. If they change the outside medium and you are still taking 1 by mu, you will not get the correct answer. So critical angle formula you can remember as sine inverse of mu of surrounding by mu of prism. Surrounding is 1, prism is mu, you can use this formula. Clear? This is about the total internal reflection. It's a very important concept. Question comes from here in the board examination. Can I proceed further? I hope you're understanding whatever I'm telling now. I'm trying to go as simple as slow as possible. Okay. Next concept in this chapter is refraction through spherical surfaces. Again, important concept. Refraction through spherical surface. And the formula is, again, we have derived in the regular class. The formula is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Remember this? It's very important formula. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. What is mu1? What is mu2? I told you, if you have a question like this, where you have a refracting surface, usually the question will come like bowl question is there, fish is there inside. That kind of questions are coming. There is a bowl of water, fish is moving, or a particle is there. That kind of questions are coming in the board exam. So if you have refractive medium and this is mu of media surrounding, this is mu of the refracting surface, and there is a point object here. Suppose ray will come, it will refract. You remember these things? So it will refract and go inside, and it will meet somewhere here. This will become U, this will become V, and this surface have a value of R. So you should use sign convention also. Don't forget that. Use sign convention. In this case, U will be negative, V and R will be positive. There are possibility of U and V both being negative also. How? See, there is a possibility that ray will go like this. It will bend like this only. Then it will never meet that side. It will come back and meet here somewhere, isn't it? Now the V will also become negative. Please be reminded about how the refraction is taking place. Don't always think U is negative, V is positive, R is positive. Not like that. Yes, R is always positive in this case. But what will be the direction of U and V is totally depending upon what? It depends upon the refraction. If bending is too much, it will go and hit here. Are you getting what I'm trying to say? Are you understanding? If you want, I'll redraw it. If you're confusing in this diagram, I will redraw it for you. What I said now, I said like if you have a surface like this, refracting surface, and this is the principal axis. Here the object is there. Ray goes and hits at this point. You will draw the normal, isn't it? Normal means this point will touch with the center of curvature, isn't it? Now the bending happens. There are two possibilities. Bending can happen like this, little bending. In this case, ray will never meet the principal axis on the right hand side. It can meet on the left hand side. It will be virtual image, isn't it? Object, image. Second possibility, it bends strong enough to go and meet somewhere here. Possible, right? In that case, this will be the value of image. So in this case, U is negative only, obviously. V will become negative. And if you see this case, V will become positive. Are you understanding? So U and V, sign convention is very important and totally depends upon how much bending takes place. So mu2 by V minus mu1 by V. What is mu1? Mu1 is refractive index of the medium from where the light is coming. And what is mu2? Refractive index of medium to where the light is going. U is object distance, V is image distance, R is radius of curvature of the spherical surface. Remember that. So this is some important concept. By using this concept only, we have derived lens maker's formula. What is lens maker's formula? Lens maker's formula. Let me write that. Lens maker's formula says that 1 by f is equal to mu 2 by mu 1 minus 1 into 1 by R1 minus 1 by R2. This is the formula where mu2, I should write why mu2 and mu1. I can directly write here mu of lens divided by mu of surrounding. I should write medium, mu of medium. So 1 by f is equal to mu of lens by mu of medium minus 1 into 1 by R1 minus 1 by R2. Like how I said, optical instrument questions are very certain. Lens maker's formula question also is kind of certain only. Mostly it comes in the examination, mostly. And how it comes, you know, they'll say that the lens is kept in some other medium. Where it is kept in air, it has some value of focal length. If the same lens is immersed in a liquid of refractive index so and so, what will be the change in the focal length? Very common question, right? If there is a lens having a focal length of, suppose 20 centimeter, how will its focal length change if this lens is immersed in a liquid of focal length how much? Of refractive index so and so. If that is given, you have to use the formula R1, R2 remains same. These two will get cancelled while dividing. In the first case, you will take mu minus 1. In second case, you will take mu of lens divided by mu of medium minus 1. So in first case, it will become mu minus 1, second case, it will become mu by, suppose 1.3 by 1.3 minus 1, like that. And everything will get cancelled and you will get the value of f. I hope you're getting my point. These kind of questions are asked in the board examination, where what will be the impact of focal length, impact of medium on the focal length. One more thing I'll tell you. If you have bifocal lens like this, then you should remember that R1 is this side, positive. R2 is this side, negative. Many students are making mistake in this also. If R1 and R2 are given, they're taking both as positive. Wrong. You will not get the answer. If R1 is positive, R2 will be negative. If you have this lens, what is it called as? Biconcave lens. Here the R1 will become negative. R2 will become positive. You may have like this lens also. Plano convex lens. If the lens is like this, in this case, R1 will be infinite and R2 will be minus, isn't it? Negative. You may have like this also. In this, R1 will be positive and R2 will become infinite. Like that, by seeing the diagram, you have to judge what is positive, what is negative, what is infinite. There is no strict formula for this. You have to see the question and understand. Plano convex. This is also plano convex. This is also plano convex. In this case, R1 is infinite. In this case, R2 is infinite. So what will be infinite, what will be positive, what will be negative is totally depending upon how the lens is. I hope you're getting my point. These kind of things should be very carefully understood if you want to solve the numericals of ray optics. Value you're saying or sign direction you're saying? See, man, what is the meaning of R1? This particular part of the lens has its own center this side. So it will be R1 this side. This side of the lens is having its center this side. Radius will be this side. So R1 positive, R2 negative. Here, this side of the lens is having this side its center. So R1 became negative. And this part of the lens is having this side its center. So R2 became positive. Got it, Simeon? Sure? Okay. So after understanding the lens maker's formula and the basic concepts of it, another thing is power. What is power? Power is reciprocal of focal length. Power is reciprocal of focal length, where focal length must be in meters. Or you can take 100 by f if f is in centimeter. I think you remember this from 10th standard itself. So if you have focal length, reciprocate focal length, you are going to get power. And power is measured in what unit? Diopters. Measured in diopters. Remember that. Power of lenses are always added if the lenses are kept in close contact. That is, if you have one lens like this, other lens like this, other lens like this, then how to find the power of combination? P1 plus P2 plus P3 will give you what? P combination. Are you understanding this? And you can see very clearly here, convex lens is having a positive focal length. Concave lens is having a negative focal length. So here the P of combination will become equal to 1 by F1 plus 1 by F2 minus 1 by F3. Remember this also. In this case actually, not for all the cases. So don't just like that add. See whether lens is a concave lens or convex lens. Because if it is all convex lens, yes, 1 by F1 plus 1 by F2 plus 1 by F3. If it is all concave lens, minus 1 by F1, minus 1 by F2, minus 1 by F3. But if it is concave, convex combined together, then you should have proper signs of focal length. And I hope you know that convex lens is having a positive focal length, concave lens is having a negative focal length. One more thing I want to say here. This is not strict rule. A convex lens can also have negative focal length. When can the focal length of convex lens be negative? Yes, if the lens is placed in a medium whose refractive index is more than the lens refractive index, its property reverses. A convex lens becomes diverging. Up to now, you know that if there is a convex lens, it will converge light, right? Light is falling on it, it will converge it, isn't it? But if a convex lens is placed in a medium where the medium's refractive index is more than the lens refractive index, it will become diverging like this, man. Remember that. Important for the board examination. A convex lens or a concave lens can change its property if the medium around the lens is having a refractive index more than the lens refractive index. So here, the refractive index of lens was more than refractive index of medium. Here, the refractive index of lens is less than refractive index of medium. So a convex lens can have a negative focal length also. Which case, if the surrounding, if the medium has a refractive index more than the lens. Now these kind of questions are asked in MCQ. They're asked in A and R. That is association and reasoning. Have idea about all these things. One more common question is there. What is that common question? That common question is, what happens if you cut the lens into two equal halves vertically? Whether their focal length increases, decreases, or remains same. Are you getting what the question is? If lens is there, concave lens, convex lens is there, cutting like this, you'll get two parts, isn't it? Like this. Now each part's focal length is more than this focal length, less than this focal length, or equal to this focal length. F will become how much? If it has a focal length of F, what is F dash? Whether F dash is going to be equal to F or it will be different from that. How much? More, less. It will become 2F. What do you say? Others? I have taught in the class, regular class. Whether the focal length increases, decreases, or remains same if the lens is cut vertically into two equal halves. Any idea? Increases to how much? 2F. 2F. This will also become 2F. Let us confirm this. What is the problem in this? So now they are kept close. Their combined focal length, which is that combined focal length, should become equal to 1 by 2f plus 1 by 2f. Am I right? You can verify it. So it will become 1 by 2f, will become 2 by 2f, which will become equal to 1 by f. That is true. It means the combined focal length is f. True. We verified. So what you are saying is correct, Yashwant and Shweta. That is when when one lens is cut in vertically two halves, equal halves, then the focal length becomes double. This question also comes in the board examination. Same way they will ask you, all the lenses, concave, convex, both. Okay. If you keep a convex lens or any concave lens and cut like this horizontally, what will happen, Yashwant? F by 2. Very good. It will remain same here. Only if you do vertical cut, the focal length changes. If this is F, this will also be F. Very important things these are. See, the past year paper questions have come from here. Or sometimes they will say, we are covering with black paper half of the lens. What is the new focal length? Remains same. Huh? 10th itself this question came. Yeah, black color, black link. If you're having one thing colored in black, what will be the focal length? It is correct you are saying. 10th only it's asked. But 12th also it can be asked. So always remember, horizontal cut does not affect the focal length of the lens. Vertical cut will make the focal length of the lens as double the original value. Is it clear to you? I hope it is clear to you. Up to now, we discussed whole of ray optics, except optical instrument. And definitely in the remaining 10 minutes, I cannot teach optical instruments by rushing. Nothing you will understand. So what I recommend to you, I will share the link of, I have taken a separate class for optical instrument. 1 hour class I have taken separately for optical instrument. I'll share that video in the group today. You can go back to home today itself if possible, see that video and revise optical instrument. If you want me to revise here also, next class when I come, I will revise it. I don't have any problem revising here once again. But I recommend in detail see the video of optical instrument and do a revision, because next week test, you are going to have optical instrument also. I have made the question paper already. So please see the clip of optical instrument. Otherwise, you will have, because in paper, out of 50 mark, at least 10 mark question will be for optical instrument. Next week paper, out of 50 marks, 10 mark will be from where? Optical instrument only. Remember that. 10 will be 12 marks. If you don't study that and come, you will miss 10 to 12 marks. And I can tell you how the questions are coming also. From optical instrument in the board examination, question will come from the derivation. That is finding the magnifying power. I hope you remember that magnifying power is beta by alpha in the case of optical instruments, where beta is the visual angle and alpha is also visual angle. Visual angle found by the final image and visual angle found by the object. If you divide the ratios, beta by alpha, you get magnification, called as angular magnification. So angular magnification of simple microscope, which is d by fe, under normal adjustment. If it is under maximum magnification, d by fe plus 1. Same way for compound microscope, under normal adjustment, magnifying power is L by FO. If it is this thing, under maximum magnification, L by FO into 1 plus d by fe. Next, telescope. If you go for telescope, the value of magnification for normal adjustment is FO by FE. And in the case of maximum magnification, FO by FE into 1 plus d by FE. Like that, you should remember the formula and come for the next test. And if you want me to revise this topic in the next class, I am happy to do that, no problem in that. But please, from your side, I highly recommend see optical instrument video and come for the next examination. Okay, I am winding off. Bye-bye, take care. We'll meet in the next class. Thank you.
Thank you.